Have you ever been asked to find the maximum sum subarray? At first glance, it seems simple. You could check every possible subarray and keep track of the largest sum, but there's a problem. That approach takes O of n squared time, and in coding interviews, that's usually not good enough. Fortunately, there's a much smarter solution: Kadane's algorithm. Here's our example array. We'll maintain two values: current sum, which represents the best subarray ending at the current position; maximum sum, which stores the best answer we've seen so far. Now we start with -2. Current sum becomes -2. Since this is our first element, maximum sum is also -2. Now we move to +1. At this point, we have a choice. Should we extend the previous subarray or start a brand new one? Starting fresh gives us a better sum, so we start a new subarray here. Current sum becomes 1, and maximum sum is updated to 1. Next comes -3. Adding it reduces our current sum. Current sum becomes -2. Maximum sum remains unchanged. Now we encounter +4. Again, we have a decision: extend the previous subarray or start fresh from 4. Clearly, starting fresh is better. So we begin a new subarray. Current sum becomes 4, and maximum sum is updated to 4. Next is -1. Current sum becomes 3, still positive. So we keep extending the current subarray. Then comes +2. Current sum becomes 5. That's a new maximum. Maximum sum is now 5. Next comes +1. Current sum becomes 6. And once again, we update maximum sum. The best subarray so far is growing. Now we see -5. Current sum drops to 1. But notice something important. It's still positive. That means we don't reset yet. We continue. Finally, we process +4. Current sum becomes 5. But our maximum sum is already 6. So the answer remains unchanged, and we're done. The maximum sum subarray is 4, -1, 2, and 1. Their total sum is 6. So what's the key idea behind Kadane's algorithm? Whenever the running sum becomes worse than starting fresh from the current, we simply start a new subarray. Otherwise, we keep extending the existing one. This simple decision allows us to find the answer in a single pass through the array. That gives us a time complexity of O of n and a space complexity of O of 1. A simple and extremely interview-friendly algorithm. If you enjoyed this visualization, consider subscribing for more DSA animations and coding interview explanations. Thanks for watching. See you in the next video.